Hello and welcome to the first session of the Python workshop. It's been a few months, a few weeks. We've been away, but we are back. We're back with more content. As you've seen, we got a new intro for this video. We're working hard trying to prepare and get new things coming. So let's get started right away. Python session 4. We're gonna get you introduced to loops. Loops are really powerful. They may seem scary at first, but they are really powerful. And if you follow to the end of this session and the upcoming one, I promise you're gonna see how useful they are. You're gonna end up liking loops. Alright, so let's get started with the first type of loop we're gonna see. It's called the for loops, and we can use them for many things. So let's get started right away with an example. We can use for loops to repeat an action a certain amount of times. Let's say if I want to repeat a number, in this case a number ranging from 0 to 5, and I want to print it all over the screen so many times because I don't know, it's my favorite number and I just want to see it in the screen so many times. So I would use a for loop for that. So how do we start? We just need to write for and then put a space, white space, and a number. Let's type number. Let's say this number is just a variable. We are using strings here. We can put anything, number, favorite number, whatsoever, as long as later when we make use of it we use the same number, it's going to be alright. So here for the example I just type number and then I place in and then range, and between parentheses I put a 5. So what does this do? Basically, if we take into this high-level programming sense of Python, we would read the following. For number in range 5, do something. It's very important to notice here that we got the double points there. Basically, the 2 points tell Python that, hey, you are in a conditional statement, or A, you're about to enter into a loop. Which is exactly what we're doing. We're entering into a loop. For number in range 5, do something, and that something is this other instruction here, print and between parentheses number. This number here is the same variable as we defined here. So as I said, as long as you keep the same name, so let's say I remove the M, I can remove the M here, that's gonna be okay. But if I keep it this way, it's not going to work. It's not going to work as it should. You see, 4 4 4 4 4 4. That's not good. But if I were to change this back to number and I hit run, you'll see it goes and does 0 1 2 3 4. Hey, but where's the 5? Where did the 5 go? Well, sad to say that range in Python is not inclusive, so it means that it's not going to put the 5. It's going to start in 0, then go to 1 2 3, but it's never going to reach the 5 because it's not inclusive. So wait, Edgar, I want to print the 5 there. I want to print numbers from 0 to 5. Okay, no problemo. Then why don't you just go on and add +1 here? That would do the trick. Hit run, 0 1 2 3 4 5. There we go. Alright, that's fine. That's a solution. Very simple, right? Okay, so continuing with the for loops, we're gonna now learn how to print some intervals. Alright, so let's say we got the for y in range, and here in this range you will notice that instead of having the 5 + 1 or simply a 5, we got 0, 20, and 3. What this does is that the first position, the 0, tells it, hey, you have to start on 0. Alright, simple. This is the first number where we start counting. And this 20 is where we want to end. We want to end on 20, so we want to count from 0 to 20. And well, Edgar, what about this tree? What does this tree do? This tree is used to step. This tree is used to give yourself intervals. Alright, so let's see how it really looks like, okay? We are just going to print the y inside the loop, and if we hit run, we get 0, 3, 6, 9, 12, 15, and 18. Okay, so let's say that instead of starting to count from 0, we want to start counting from 1, and instead of going to 20, we want to go to 30, and instead of counting by 3s, we want to count by 4s, and okay, that should do it. Let's hit run, and as you can see, we start counting on 1, then we add 4, so it's 5, then we add another 4, so it's 9. That's pretty cool, right? So I'm gonna point a question now. How would you do with what we've seen so far? How would you do to make a loop that prints only the even numbers? Or how would you do for a loop that would only print pair numbers? That should be really easy with the things we've seen, right? Okay, so I will give you some time to think about it. Leave your comments in the video if you want, if you found a way. It's a good way to share and to let others know. Okay, so now let's get into a real world example. Why can for loops or loops at all be useful? It's got something to do with PCR, which we are really familiar with nowadays, right? Because of this COVID thing, some of our friends or colleagues are undergoing the PCR, and basically what PCR does is it replicates the DNA of the sample. It creates lots of copies of the DNA in the sample, whatever there is there, bacteria, COVID-19, even your own cells. It replicates everything, and with that, what we do is that we put those into the sequencers, and the sequencers are going to tell us just strings of letters A, C, G, and T if we are talking about DNA, or A, C, G, U's if we are talking about RNA. So basically this combination of letters A, C, G, T's, and so on could be, from a programming perspective, compared to a string. Basically, when we do bioinformatics, we use strings to do this analysis. But instead of having these tiny whiny strings like here, what we end up having is terabytes, yeah, gigabytes, terabytes of text files with only ACGT. So can you imagine a file that's super long, terabytes long, but only ACGTs? Yeah, that's a nightmare. And that's why these programming tools are essential. So without more further ado, let's dive into it. Let's first create a string with some DNA. I'm going to call it DNA sequence, and then I'm going to add ATG, GAA, which makes no sense. It's a random sequence that I made up. Once we got this sentence or this sequence defined, what I'm going to do is I'm going to print each one of the characters of the sequence. And to do that, I will use a for loop. So I'm gonna write for char of character in DNA seq, 2 points. So for each character in DNA seq, do something. And what I'm gonna do is print. Also, I want to point you to this white space here. Alright, this is automatically created by Jupyter. Be careful if you're using another editor, because Python is white space sensitive. So if I press the space, it's fine, it creates it, but if I go and select this, you will notice that, hey, it's actually a few white spaces, you know. When I press the enter button, it automatically tabulates in the position where I want to go. It's very important to have indentation inside loops, because imagine this becomes super complex, as you will see later. It's very important to have this indentation so that I can see what things are actually inside the loop. Alright, so let's hit run. And when I hit run, what happens is that for each character, it's going to print the character. So at the end of the day, I get this horizontal string, which is turned into something that seems like a vertical string, but it's not actually a vertical string. It's basically just printing each one of the characters in a different line, because I'm using a print here. Alright, so let's continue, and let's continue with more DNA, with more bioinformatics stuff, and let's see what we can do. For example, we can count how many times a letter appears. Why is that important? Well, in bioinformatics we got these statistics that tells us the percentage of G's and C's, and the relationship between the letters, if one is more frequent than the other, and with those we can get some statistics and analyze the quality of the data. So let's count. Let's count how many times a letter appears in this sequence. So for this case, same old, I'm using this same code, but I'm just extending it. Alright, so I'm going to add a count, and I'm going to set it up to 0 before I get into the loop, which, as you've seen, it's grown a little bit longer. Okay, so what I've done here is I've kept the for car in DNA-seq, then I've put the 2 points, and then in the next line, instead of putting the print, I've placed an if. Then this if is going to check if a condition is met. And what is the condition? The condition is that the character equals a. Equals, remember, 2 equal signs, then we put the space, and between the quote marks the string or the character we want to compare it to. Then another 2 points, and as you can see, when we go into the new line, we're gonna have this other indentation here. See, double indentation. We got the first one for the if, and then we got a second one here. Okay, we got this one here, and we got a second one, larger one here. So what we do here is we put a count and plus equal 1. So what this will do is that in each iteration, every time Python finds an a, it's going to add 1 to the count variable, which at the beginning is 0. Before we enter into the loop, we set it to 0. So let's say we are the program and we go into the DNA-seq. So we will see this first a, and we say, oh, plus 1. Then we see this t. We will do nothing. We will just go to the next one. Then we see this g. Okay, do nothing. Then this other g, nothing. Then we got this a. Oh, plus 1. So we got plus 1 and plus 1. We got already 2. Okay, so at the end of it, it's gonna have the final value of that a count. So what I'm going to do is I'm going to print the total. So once it's finished, and notice here this print doesn't have indentation, it's at the same level as the 4. Can you see this F falls right into the same place as the P here? This means that these two are in the same indentation, which means that this print is outside the for loop. So it's gonna happen after it's finished. And what I do here is I print we have a number ace in the sequence. Then I put the format and this variable here. Remember that this thing here, these brackets with the 0, is used to refer to this a count, which is introduced by the dot format of the string. So let's hit run and see what happens. Okay, it says we have 5 a's in the sequence. Alright, so just to show you, I'm going to type in here a count, and let's say I'm going to put print. I'm going to put print here, print a count, and hit run. You'll see that 1 1 1 1 1 1, because each time I got a letter, each time I'm iterating through, I would print. So the a count only changes when I find a new one. So first I find one, then no, then I find a new one, then another one, then I don't find any, yeah, and so on and so forth. So I would just remove this one here and live with this one. Oops, here we go. Okay, so let's continue and see what else we can do. So let's say, for example, I got a DNA sequence that comes from the lab, and well, the guys didn't do a pretty good work because they're using an old machine or something. And what happens is that that some of the letters come with uppercase and some come with lowercase. Oh, that's gonna be really bad, right? So what I'm going to do is, before I jump into the loop, I'm going to use this method, which is called upper. And what I'm going to do is dnaseq equals dnaseq.upper to convert this DNA sequence into uppercase. Then I will also set the a count to 0, and I'm going to create a new variable which is called seq_length, which will contain the length of the sequence, as you've seen in the previous videos about strings. And once I got that, what I'm going to do is jump right into the for loop. So what I'm going to do there is to check if the character uppercase A appears there, and I'm going to add it to the a count. And at the end of it, I'm going to print we have as many a's in the sequence. I'm gonna change this one, instead of tiny, I'm going to put it the uppercase. And then after that, we're gonna print another one which says total sequence length is BP. BP is best pairs. So basically here I'm making use of this sequence length to express how long this sequence is. So let's hit run, and after it finishes, it tells us, okay, we have 5 A's in the sequence and the total sequence length is 12 BP. So let's say I go back to this here, perfect sequence, and I hit run. No problem, it's the same, it goes smoothly as before because I'm using the upper here. Alright, so whatever A, it gets converted into uppercase, and since I'm checking uppercase, it's completely alright. Alright, so now let's do something more, right? Let's try to count each one of the different nucleotides, which, thanks the Lord, there are just 4. We got the adenine, cytosine, guanine, and thymine. And what we're gonna do here is just define 4 counters: A count, C count, T count, and G count. And then we're gonna go again with this sequence length to store the length of the DNA, and what we do is in this loop here, for character in the DNA sequence, we are iterating into each one of the characters, and we got 4 checks here. We check if character equals A, if character equals C, if character equals T, or if character equals G. And in each one of them, what we do is that we add +1 to the counter, to each respective counter. So be careful here, don't miss up. We are using the A for the adenine, the C for the cytosine, and so on. So once we got that, we calculate the frequency of each letter. And what is the frequency? Well, the frequency would be basically, in this case, as we are doing it on percentage, we take how many times this letter appears, and we divide it by the total length, and then we multiply it by 100. So we get it in percentage. So basically, a freq equals, and between parentheses, a count divided by sequence length, and then we close parentheses and multiply by 100. And we do this for the remaining letters. Okay, once we got that, what we do is print with this formatting, and as you can see here, I type we have the percentage of A's. Here we got this first bracket number, which is a 0, refers to the A count, and this other bracket number here, this one, refers to the second one, which is the A freq, which I've defined here. So if we hit run, boom, there you go. We got our first statistics, or first genetic statistics, so basic. And good news is that this basic piece of a script can work on a super long sequence. So let's say I would just go on and put this here, and let's put it randomly here. There we go, and I hit run, boom, super fast. It calculates everything like super fast. And here we go, we got the statistics again. Let's make it a bit different, because I copied the same, so duplicating it would just keep the same numbers, the same proportions. So let's get different numbers here. I change and add an A, and we got different numbers here. Okay. So now let's finish this session. I hope you are enjoying so far. We will continue on the next session, but to wrap this one up, let's finish introducing you the while loops, the wild dangerous loops. Why do I say dangerous? Because they are. Because they are very dangerous if we are not careful. They can leave your computer stuck for hours. They can make your computer freeze if you're not careful. So beware, word of caution, be very careful, think through before you do any while loop, and if you do a while loop, beware. So while loops compared to for loops are slower, and they don't provide us much control. So why do we actually keep using them? Well, I really don't have an answer for that. It depends on the day. I think maybe you wake up with this mode and you say, oh, today I'm feeling more like a for loop. Or the next day you maybe feel like, oh, why? I would try with a while loop. While I'm waiting to decide, I don't know. Depending on the situation, I would stick with one or the other. If you are good at making the exit condition on the while loop, I don't see why not. If it's easier for you to understand, if it's easier for you to implement, as you can see here, it's very simple to write down. We don't have to go on for boom, in, range, blah 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 whatsoever. Here we just go on and write while number is less than 7, do something. So basically what I'm doing here is I'm defining a number and I'm giving it the value of 3, and then I will put the while loop. And to create the while loop, what I'm doing is I'm simply writing while, as in plain English, while, and then I put my number here, my variable, and lesser than 7, and of course 2 points. Okay, so while my number is smaller than 7, do something. Very simple, right? It's very easy to read, very easy to follow. Okay, so also remember 2 points and then indentation. And inside this loop, what we do is we print the number. Okay, we print the number, and then once we print the number, we increase the value of the number, and we increase the value of the number in this case by 1. So what this will do is I'm the number, and right now I'm number 3, so I get into the while loop. So I make 3, and this 3 gets into the loop and it's print. Oh, I print 3. There we go, we print 3. Then we increase the number by 1. So if I was a 3, now I'm gonna be a 4. Okay, so let's do the loop again. I'm a 4, so I print myself on the screen. So that's a 4 on the screen. So on the screen we see that it prints 3 and 4. Okay, and now this number increases again. It increases again to become a 5. And once it becomes a 5, it goes on again into the loop. It prints itself, it prints the 5, and it increases to the 6, and then the 6 goes into the loop and it prints the 6. So we got the 3, the 4, the 5, and the 6. And when the 6 is into the loop, well, it has print itself, and then it increases again, so it becomes a 7. Oh, and this poor 7. Oh, now that I realize, I prepared this a while ago, but this is like the problem with the number 7 friend we got here in Barcelona. It's like we are not allowed to have meetings of more than 6 people because of the COVID, of the measures of the COVID. So what happens with the number 7? It cannot get into the party, it doesn't get into the loop, he's not allowed to. So if I hit run, you're gonna see that it's 3, 4, 5, and 6. Sorry, number 7, you're not allowed. You're not allowed. We have to avoid propagating the virus. So you are not welcome into the while loop. Okay, jokes aside, this is very important, because we are counting, we are adding the numbers so that at some point we reach the exit condition. Let's say we got a situation, and this is why I told you, be careful, think very clear before you go into a while loop, because it can really mess up your day. And this is going to be the closure for today's session. I'm going to show you the never-ending loop. So before I do this final demonstration and I make my computer get stuck, please hit like on the video, put a comments if you find it helpful, if you want me to explain in a different way, if you think this new way I'm trying of explaining things makes it easier for you to understand, just whatever thing that can be useful for me to make better videos and to explain it better for you, please do so. I will be glad to receive your comments. And also, don't forget to subscribe if you haven't subscribed, and to turn on the notifications. Okay, and I will see you in the next video. So here we go, the never-ending loop. How do we do that? We just write here while true true with capital letters. This is a type of variable. This is a Boolean variable. We put the 2 points here and then we print. This loop is never ending, like the never ending story from Limao. Alright, there we go. Never ending loop. Are you ready? Let's hit run. Remember that here we got this button that says interrupt the kernel. Alright, so just in case if you need to do that, I hope your mouse reacts. So there we go, the never ending loop. That's it. Here we go. Never ending, never ending. Can you see? It's there all the time, all the way down, all the way down. If I scroll down, it will do. It will keep moving, 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 adding more, adding more. Yeah, there we go. So thank you very much. And also don't forget to subscribe if you're not a subscriber, and to turn on the notification. This is really important. Please go on and press that bell so that you won't miss anything. We're gonna be creating new videos about 3D printing, about Python programming, and a lot more. We are creating our own music for the videos of 3D printing. We are creating our own content, and we are just 2 people. I'm Edgar, and my designer, my co-worker that's from the Philippines. He's in the Philippines. They're stuck with the COVID, so we need all the support, all the love and support we can get for this project, because we have to make it work. We don't want to be shutting down the project in a few months because of this pandemic. So please spread the word and show us your love. Help us and we will help you. We will bring more content. We will listen to your comments and we will create more content to help you out, because this is what we've wanted to do from the beginning. We've wanted to create content to teach people, to help people learn, to help people grow and to reach their goals. So please help us and we will help you with our content. Take care and see you soon.